Welcome to another episode of Digital Fluency, the only podcast where you are guaranteed to get smarter about the digital world or your money back. Digital Fluency is a special podcast series from the good folks at the Studio for Teaching and Learning Innovation. I'm your tirelessly titular and always charming host, Adam Barger, and I'm the instructor for the William & Mary course entitled Digital Fluency, Footprints and Philosophies, which provides the content for this series. Every week, we review what happened in class and discuss ways to apply these ideas to our lives. I am joined, as always, by student producer extraordinaire, Jacob Hall. How are you, Jacob?
Oh, I'm doing so well. Got my coffee this morning, feeling very talkative.
Awesome. It's good to be talkative on a podcast, I think.
Oh, yeah.
I have good news for you, Jacob.
Ooh, what's that,
Well,
Adam?
I don't know if it's good news for you. It's good news for me. I've made a big decision. I mean, big. I think I'm going to go all in on this Bitcoin thing. I'm going all in.
You're going all in on
Yep.
Bitcoin.
Yep. I'm going to get all the Bitcoins that I can get.
Why now, Adam?
Well, I figured out the secret really is the blockchain.
Oh,
Blockchain is going to help me do it.
that makes sense.
Yeah, and once I discovered the power of blockchain, I feel like we need like an echo or some sort of like sound effect, like
a reverb.
blockchain. Like it can do so much. So I'm trying to make like my data, my personal data, super secure.
Ooh.
And I think I found a way.
How's that, Adam?
Blockchain.
Wow.
Blockchain is the answer. And you know, while I'm at it, I was like trying to solve all these other life mysteries. I think I've figured out a way to like hack my smartphone to make Siri sound like Darth Vader.
No way. What are you
Absolutely.
using for that?
Blockchain. Yep.
Blockchain.
I'm pretty sure blockchain is going to do that. And not only that, it can like help me lift really heavy things. Like remember
No
in elementary
way.
school, those those different pulley systems.
Uh-huh.
One of them was the blockchain. Do you remember this?
I don't know if I do. Adam, are you sure you know what blockchain really is?
No idea, brother. No idea what blockchain is. And the crazy thing is, we learned about this in class. We had a special guest, and so we're actually going. In today's show, we're going to go back in time because we covered blockchain at the beginning of the semester, along with kind of Web 3.0 and Internet of Things. Remember that? Mm-hmm. The person who helped us with this topic wasn't available to come on, so we had to delay his presence. So we're actually going to go back in time.
Ooh, cue the Alice in Wonderland,
Yes.
like,
Yep. You know how we're going to go back in time?
how's that?
Blockchain.
Oh, nice.
Yes. So blockchain is the topic, and I am very happy to introduce our expert and guest, Troy Wiipongwii from the Blockchain Lab, is here with us in the studio. Troy, how you doing?
I'm doing well. It's great to be here.
Thanks for making the effort to get in here. COVID-19 and all. Here we are all masked up and talking. And I have lots of questions. I was in the class where you came and spoke to us, and I still have lots of questions. And I bet a lot of people think that way about blockchain. So before we get to the actual topic and the question you get probably most often, of what is blockchain, let's talk about you for a second. How did you get to where you are now at William & Mary, and how did you come to be interested in the topic?
Sure. Yeah, I'll go back to 2012, 2013. I was running a fintech company during that time called Debtless Community. And the goal of Debtless Community was to help low-income community members get out of debt faster by leveraging a group discount buying method along with partnering and pairing with local buy first patterns to provide deep discounts that could then be used to pay off debts. And the way that we did that was to actually have businesses give back customers script money, which is a local printed currency that they then would take over to the local bank, and the local bank would partner with us, and then they would go and exchange that money and go and pay off their debts. That was clunky. It was slow. It was inefficient. And during that time, I was also looking for alternatives, and I came across Bitcoin as a potential application as a digital currency.
This is in 2012, 2013, you
Yes.
said? So please tell me you bought a bunch of Bitcoin back then and now you're a bazillionaire.
I did not. I was not looking at Bitcoin as a speculative investment. I was looking at it purely as a digital currency that could be used within our network. to help people get out of debt and actually create a systematic database or ledger for our local businesses, the collection agencies, the local banks, and our customers to be able to see and understand that they were all reconciling the same accounts.
Mm-hmm. Okay.
And from there, I continued to learn a bit about it. I learned that I did not have the technical capacity to build that within the system at the time. Even when Ethereum popped up, it was still so new. And I was not a computer scientist. I like to think of myself as a technologist and social scientist. I shut that business down. I went back to school, came to William & Mary for grad school, published a few papers on blockchain and international development with a couple of colleagues, classmates, and faculty members. And in early 2018 or mid 2018, I put together a proposal for what a blockchain lab could look like at campus at William & Mary. And in 2020, the provost provided some funding to create the lab, which is kind of where we are now. And throughout that time, there were different entrepreneurial endeavors within the space.
Wow, that's a really interesting background. And I'm curious, Jacob, as a student, have you heard of the blockchain lab?
No, not yet. And I'm really excited to hear about like what y'all do and what the sort of mission is for the blockchain lab.
Yeah, when I saw it pop up, well, actually, I think you contacted me, Troy, and said, "Hey, can we look at some collaborations and things like that?" It was news to me, and so this is very like ground level, which is really interesting to kind of see things. You know, what was the spark to kind of start this, and where do we think it's going to go? And then, of course, COVID, and then everything sucks for a year and a half, and but you've still been making good progress. You've still been doing things, so maybe we can get into some of that. So I definitely want to talk about your programming and your different research initiatives, but let's go to the basics and ask that big question that you probably get all the time. What is blockchain? And I know it's not a way to hack Siri to sound like Darth Vader, but if it could, that'd be a bonus.
Sure. I do get the question all the time, and sometimes I wonder if it's worth giving the actual technical definition or giving examples first to explain the potential impacts of it.
Probably examples. I'm a simple-minded man, Troy.
Awesome.
Yeah.
I will start with the technical, though, first, and then give the example.
Well, that's why Jacob's here. He can understand the technical.
I'll do my best.
Yeah, a blockchain is really just a data structure. The way you have a database, you have your rows and columns. Everybody understands that. You can go and you can look at an Excel sheet. You can put information in. In the row, it's related to an entity. In a column, it's related to a variable. This is a form of a data structure. There are more technical computer science data structures like linked list and dictionaries and things like that. A blockchain is essentially the same thing. You have a record of data that's recorded in a block-style fashion that is then connected to another block in a chain-like format that's connected through cryptography. And the purpose of creating this data structure like this is to ensure that there is a record of origin and provenance for that information there, so that it's not easily changed and it's auditable. That is the shortest definition you could possibly have.
Wow. How are you doing so far, Jacob? I think I got about halfway through.
I think I have read a bit about blockchain, so what you've said so far I think makes sense, and I can try to help clarify and make sure that I understand exactly what it is.
So one of the things, just on that, like one of the things, like your first part was crystal clear for me. When you talk about the information being structured as a block, can you just give a little more on that before you go any further? What do you mean by a block?
Sure. It's a block, which is a terrible way of defining it.
Excellent. And that's the show, everyone.
So if you have a table of hundreds of entries, right? My understanding, and please correct me if I'm wrong, this is a great opportunity for me to clarify my understanding of blockchain, is a block is just a certain number of entries, or maybe a time frame of entries. So if we have a block for every day, say I make transactions every day, and at the end of the day I end that block, I can sort of stop that block and sort of complete it. And then my understanding is you can then connect it to the previous block by including maybe some sort of cryptographic hash of the previous block in that block.
Absolutely.
And then the reason why that's important is because then any subsequent blocks will have to have the correct hash of the previous block. Otherwise, it's clear to anyone who runs the computer program that the blocks are not in that perfect chain.
What do you think?
Yeah, that's a good way of explaining it. Yeah. So what is in the block is well, it depends on which blockchain you're talking about. We can use Bitcoin as a starting point. It's transactions of Bitcoin. There's 3 of us here. I want to send you 5 Bitcoin. I want to send you 3 Bitcoin, and you want to send him 2 Bitcoin. These could all happen near simultaneously, in which case they would end up in the same block. What would happen was there would be some calculations that would check our balances, make sure we all had the appropriate amount of money to do so, to make those transactions, and then that would be recorded and timestamped and provided a string of numbers. So all of those transactions take place, and we now have a string of numbers like 1, 2, 3, 4. In that completes the block. We go on and we want to make some more transactions. It has to check the balance. It will go back and check the balances that have been recorded on the previous block to ensure that we have that information. And if we do, we can record those transactions. Now, that 1, 2, 3, 4 is very, very important. If you decide you want to try to hack it, or you decide you want to try to hack it, or I decide that I want to try to hack it, even changing a period in that transaction is going to change 1, 2, 3, 4 to ABCD. If we know that that's supposed to be 1, 2, 3, 4, and it turns to ABCD, something's happened. So that allows us to continue to keep track and ensure that the information from the previous section has not been tampered with. That provides a ton of opportunity for us to ensure that we can trust and authenticate information in the digital space that we haven't been able to before.
So that helps me understand a little more about why the computing power, from my understanding, is getting exponentially more. It's getting higher and more powerful to make these transactions. So I saw on the Twitter today, somebody posted like a picture from like 12 years ago, and it was a video game tournament, and first prize was like $500, and second prize was like $300. And you get all the way down, and like 5th through 8th prize all got 25 Bitcoin, and they're like, it wasn't even worth anything, and so like, we'll throw in some Bitcoin as a prize, and if that person 12 years ago like held on to that, they could potentially be, doing pretty well right now. And so then I matched that with another post on the Twitter, and I don't know if this is true, but they're like, a single Bitcoin transaction consumes as much energy as an entire house does in a week or something like that. And so I'm like, wow, so the computing power behind this is pretty intense, which tells me those blocks, those strings, are much more complex than ABCD. It's super, super long and complex. Is that a fair description as why it takes so much computing power?
So the computing power for Bitcoin, what you're talking about is something called proof of work. This is a consensus mechanism. I can define that at a later point if you want. But basically, this is the way the network reaches agreement. Proof of work is a mathematical puzzle. You're creating essentially a hash, which these are the cryptographic hashes that have a certain amount of zeros in front of it. Bitcoin says that we want to make sure that it takes 10 minutes to validate these transactions. If you're looking for this 5, 6, 7 zeros before your hash, it takes a lot of time. But if you're operating on your Mac laptop and I'm operating with the most complex supercomputer, I can dominate the network. You want to essentially create a level balance within the network to ensure that no one person or no group of people control 51% of the network, which then makes it hackable. So this is really just a way of ensuring like a balance and a level of decentralization within the network. So yeah, these hashes do get more complicated as time goes on, but that is a function of continuing the decentralized nature
Okay. All right. I'm with you. So sorry for that little tangent, but
Yeah.
I think you were then next going to go to some examples or some other applications, or is there more on the technical we should cover?
No, I think real estate is always the easiest way to go when you're trying to describe the benefit of blockchain, separate it from these cryptocurrencies. I buy a house. At some point, I might want to sell the house. In order for me to buy the house, either it's a brand new house and I am the original owner of it, or I buy it from someone else. There's a lot of due diligence that goes into ensuring that the person beforehand has the actual like title and deed to the house and can sell it to me, make sure that they don't have liens and things like that. If this information is recorded from the very beginning of time, we can go back and we can track pretty clearly who actually is supposed to own the home. There are places in the world where that's not necessarily true. If everything was recorded on blockchain, we can prove those transactions much easier than we could under normal situations through the paperwork, going to your local county, looking it up, making sure that there's no taxes at the local level as well that are outstanding.
Not to mention paying the title insurance company and all these things in case there is a mistake made.
Absolutely.
So there's a efficiency argument as well.
Absolutely.
Okay. I like that example. Does that make sense to you, Jacob?
I think it does. Yeah. I mean, I'm sure like any application, like there's a lot of details that involve like the actual design of the blockchain for that purpose. But yeah, from like a very like, I don't know, abstract level, I think that makes sense.
So, since I was in the class, I remember some of the other things you talked about. Could you go over one of the examples that I think interested the students a lot and me was this potential connection to personal data. Is that too far down the rabbit hole, or could we talk about that?
Sure, we can talk about it.
Okay, so if I remember right, I'll try to set this up because Jacob and I have talked about this a fair amount on the podcast, and that is like ownership of data, how big tech is, they're interested in your data, but they're much more interested in your attention. And one of the ways they can hold your attention is to know more about you. Mm-hmm. And so they're essentially making money on what you search for and what kind of coffee you like and where you go and all kinds of data. Mm-hmm. And so the idea of knowing what data is being used and how it's being used is not so easy. But if I remember right, there could be some blockchain applications to help fix that in terms of ensuring you own and control yourself.
Yeah.
So what do you think?
Yeah. The first thing I would like to say is there are other solutions that are not technical solutions, like regulation and policies that are being put in place to know exactly what your data is being used for. Mm-hmm.
Which is happening now. I don't know if you all saw that announcement was it from Apple?
Yeah.
And Jacob, we talked about this, like the idea of having platforms or like the App Store, these collectives that sell the applications mm-hmm. be more open about what's used from you and how it's used.
Right.
And so not necessarily putting the onus on the app company to disclose things in a certain way, but to get into the App Store, for example, you have to have this kind of grade, where people can clearly see what they're getting into.
Right.
And just like a week or so ago, or very, very recently, Apple announced they're going to do that.
Yeah, which is very exciting to me from a privacy perspective.
Yeah.
Yeah. So yeah, good point. We don't have to blockchain everything, but but still, I think the concept is good because for me, I really like the idea of being able to control and maybe even make a little money off my attention and data.
Absolutely. And this is where blockchain comes in. There's assumption in the previous case is that you're also trusting the government. The government's also tracking your data, and that there's no malicious intent for which type of regulation they're pushing. So there's a lot of trust that's being placed on the social systems that exist today to ensure that route of policy and regulation is good or comparable to the alternative. And in the blockchain space, there's a few ways that we can own our data. And the foundational part of that is public key infrastructure. If anyone has tried to transact with cryptocurrency to date, they're given a public key and a private key. Your private key is essentially like your password. Your public key is like your username on Reddit. This is how you interact. This is how people know like who you are to send the money to. And your private key is how you ensure that it is in fact you and no one else has like copied your username, like a fake on YouTube who puts a picture there and says, I'm Donald Trump and I approve of this message, which is very easy to do without using this public key infrastructure. Like this is the foundational piece of creating something what we call verifiable credentials and also self-sovereign identity. If we have a strong cryptographic identity that we can then start to aggregate our personal information on and hold it ourselves, it provides the opportunity for us to, one, create trust in a digital ecosystem that doesn't necessarily have a ton of trust in engaging with people that they don't necessarily know, and also gives a level of comfort to us knowing that no one can get behind that security breach for information. So it's creating like a two-way signal for us to be able to engage in a digital space. And what this would look like is currently what you do when you want to go to a website is you sign on, you put in your username and password. In the blockchain space, there are wallets. Have you heard the term wallet?
Yes.
Okay. A wallet is assigned a public and private key and some seeds, and you have your digital coins in there. Well, because this is all built on the same infrastructure, you can have your certificate for your social security number or your certificate for your diploma, like all within this wallet. And what you would do is you would have new websites where it's not your username and password. You're now connecting through your wallet. They can ask you for permission for certain types of data. The amount of data that you have to give is only the bare minimum, what they need. They need to verify that you are who you are. They can do that just through your public and private key and know that you have a social security number. They don't need to control it. They don't need to manage it. That fundamentally changes how we're interacting with the world and the digital space and how much control that we have. Now, when you mention the monetization of that, as we sign on, maybe they do want to collect some user survey data. And they say, hey, we want to target this particular demographic. Again, we don't have to tell them our exact age, but they want to know we're between the ages of 18 and 24. We've got our birth certificate in there. Our birth certificate can just, the way that they had collected is it's either true or false. I'm in the 18 or 24. Are you male, female, non-binary? We need to collect this information, and we're willing to give you $5 for it. Again, you don't have to tell them exactly who you are, but you can interact that way. And at the end of the day, they're doing these calculations. They've created some outcome or output that's necessary for them to make some decisions. And at the end of the day, you're still owning your data, but they've also have the outcome that they need without necessarily knowing exactly who you are.
I love it. I love the idea that like there's the possibility of me getting the benefits of companies knowing a lot about my habits and my demographic and everything without having to match it to me specifically. They need to know, they'd be interested in knowing where, middle-aged male with a family, what kinds of things I'm buying online. Yeah. And it's not necessarily attached to my name. It's attached to these verifiable credentials. Yep. I love that idea. Yeah. Jacob, what do you think?
I really like this idea, and I'd like your help sort of connecting it back to the idea of blockchain specifically. So if blockchain is tracking changes to a ledger over time and sort of verifying each block of changes, what types of changes are we making to our personal data or the way that we share them that would be managed in a blockchain?
That's a very good question. From the blockchain perspective, those credentials that I'm talking about, that public and private key is being issued through a blockchain through certain standards.
Okay.
So for a identity to be considered a authentic identity, it should have an identity hash of XYZ. If it doesn't have that, then we know that it's not issued from a chain. And I use blockchain interchangeably with distributed ledger technology in general.
Okay.
They are different. They have different structures. You have things called DAG-like structures. That's way too complicated to get in for 45 minutes. But it's a different way of creating a distributed system.
Okay.
But essentially that's what the blockchain is for. If we want to give up information, and this transaction takes place, again, you don't necessarily have to know what information is being, you don't necessarily have to know everything about this particular person to be able to make decisions, but there's still a transaction that takes place. I've asked for authorization to use your information, and I have, in fact, used your information. If there is a way of tracking publicly what a company is doing through the transactions that are making, we can say, hey, you violated the terms of agreement because this transaction has been recorded. Again,
Right.
My personal information hasn't been exposed necessarily, but we can tell that company has not made a transaction or a decision on that data that they claimed that they've used it for.
Interesting.
So that's where blockchain comes into play. It's creating that infrastructure for identity, and it's creating that ledger for those transactions that are not just cryptocurrency transactions, if that makes sense.
Yeah.
And that's all recorded.
Okay. That makes sense. Thank you.
Yeah. And I'll go into one more thing. This is also technical, but it's easy to understand.
Sure.
Let's say that in a different world, we have this, but it's more of a hybrid.
I'm confused. No, I'm just kidding. Go ahead.
And we allow the companies to hold our data because we haven't reached the level of cost reduction in storage and things like that for our personal devices that allow us to hold this. And we still need to take advantage of their immense size and ability to reduce costs through cloud storage and things like that. And let's say we have our data in just a traditional Excel sheet format. So our first name, last name, age, blah, 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 blah. And our information's there. If we were to create a cryptographic hash of that, it's very unique to our information, right? Which is what we talked about, that 1, 2, 3, 4 versus an ABCD. If we say, we have the right to say delete my information. If we say delete my information, they have to send us back a record that has no information in it. So they're hashing an empty record essentially, which has a very unique hash. Every time we want to make sure that they didn't actually save our information, we can request that hash and compare it to make sure that there's no new information that's been added on us.
Okay. So a little bit like that right to be forgotten case. That we
Yes.
talked about.
Yeah.
Oh.
Okay. And sort of the legal background to that would be making it like illegal for a company to return a hash that wasn't exactly what they have for you. Sort of like we could make it we could hold them responsible if they were to disrespect that ledger.
Absolutely.
I see. Interesting.
So one of the things that we did in the class where you visited, Troy, was we were trying to relate this obviously to the big idea of being a digitally fluent, citizen, a digitally fluent learner, and we were connecting it to Web 3.0. And I thought you did a really good job of that. And I was wondering if we could use that for our kind of 3 tips or 3 takeaways for folks. And you set it up like this. I think there's a quote here from Fabric Ventures where it says, where Web 2.0 was driven by the advent of mobile, social, and cloud, Web 3.0 is built largely on 3 new layers of technological innovation. They are edge computing, decentralized data networks, and artificial intelligence. And then you kind of attached a blockchain perspective to those 3 things. So if you're willing, I'd like to maybe introduce those as kind of our 3 takeaways, maybe not takeaways, Jacob, but like our 3 kind of tips to be thinking about or be aware of which does not have the same ring as time for the takeaways, time for the interesting tips on blockchain that you might be able to apply in the future.
3 things you might be interested in.
3 things, yes. So see if you can do this on the fly, off the top of your head, because I'm surprising you with this, Troy, but edge computing, let's start there.
That's bringing our information or computing powers closer to the devices that we're using.
Nice.
So that's the laptop that you're using right now and the cell phone in my pocket. Any other digital device or our IoT devices like our refrigerator that have computers in it now. Those are edge devices versus your more centralized, depends on what you mean by centralized versus decentralized, but centralized meaning the companies own the servers or your cloud devices where they're operated by AWS or Google Cloud or whatever the case may be. Yeah.
And obviously, if we're bringing these things closer to our devices with our phones and things, blockchain could have a role there in not only the security, but also the efficiency in how we use them.
Absolutely.
Okay. So second one, decentralized data networks. We touched on this already, but any other connections there?
Decentralized and distributed systems are not just blockchain. As I mentioned before, you have distributed ledger technologies, but you also have distributed systems that have been around for a very long time. Like this university has a distributed system. Large corporations have distributed systems. They've been operating across, time and geography for quite some time and have been trying to sync themselves up. With the continued acceleration of distributed ledger technology, we're seeing potentials for better syncing of these systems, and as a result, more networked effects and trusting information that's happening across these systems will continue to be consistent.
Yeah, and I think you noted in your presentation that you said the empowerment and ownership of these data gives users the ability to generate value, which I think that, again, that speaks to me, not only because I can really understand it, but I can see where in some ways in the digital world, I do not feel empowered. I feel owned, not in ownership.
Absolutely. So connecting those two thoughts there, again, going to the edge devices, this is where we like to keep our personal information. Obviously, it's still stored somewhere as well. The increasing computational power and storage power there will give us the right or the technical ability to store that if we move in the direction of distributed systems. Those distributed systems obviously are all of these networks, these edge computing devices connecting together, and blockchain providing a networked layer for us to trust all these things that are happening on my cell phone and your cell phone in terms of information.
I like that one. That one seems really applicable. And this last one does too, artificial intelligence and machine learning. Is there a connection there?
Yes. And going back to companies wanting our data, well, how do they typically make decisions or extract knowledge from data? They usually use statistical models, descriptive statistics, machine learning, artificial intelligence to derive, some type of information from that raw value. With the creation of this new networked distributed world, there will be new ways in which machine learning and artificial intelligence collects that data and makes decisions. That computation can come closer to our devices. It's already been trained a bit from other information it's gotten from other devices, and it comes here and it adds that extra information, and then it, provides an output for that company. We call that federated computing, and that's going to provide a lot of new opportunities for having personalized services, personalized health, personalized marketing that isn't cringy feeling, that we can also
and
take
probably
part of.
more applicable.
Yeah,
more targeted. So this has been really helpful. And before we kind of give some closing thoughts here, I wanted to see what's next for you in the blockchain lab. What things do you have coming up? How can people maybe plug in, learn more?
Sure. Actually, just 2 days ago, we had a a seminar on NFTs, non-fungible tokens. It's the new hot topic after decentralized finance. We had a really big turnout, and we're going to continue down that path. We're actually going to have a talk on verifiable credentials very soon. We're going to have Mercy Corp and the Danish Red Cross come and talk about how they're going to be using blockchain in the humanitarian and international development space. From the research side, we have 6 research streams that were funded last year that will conclude in June, and we will continue doing a call for proposals to continue to incentivize faculty and students to engage in collaborative applied research in the blockchain space. So there's opportunities for students to partner with faculty. My own personal research stream is on blockchain governance, and the overlap between data science, blockchain within the hospitality and tourism space. That's something that I'm super, super interested in. So I will also be taking on students, and the data governance and the blockchain governance piece is a huge component that we didn't get a chance to talk on today. You're talking about open systems. How do open systems reach consensus, not at just the technical level, but the social level? You're talking about a new, not necessarily a new form, but you're talking about moving theory of democracy and decentralization from your governance and political science and economic research into an actual applied setting now. Who are the stakeholders? Are we moving to actual stakeholder capitalism versus shareholder capitalism? Like, what does that actually mean? These are topics that I really would like to explore, and they're something that we're going to need to get a handle on, because there is a dystopian world that can pop up as a result of allowing blockchain to happen in a very organic way with the way people engage with each other today.
Oh, shoot, man.
So
I'm scared. Skynet's coming. What do you think, Jacob? Do you think this is something that students and others in the William & Mary community would be interested in?
I really think so, especially when you just started talking about how it can be applied to so many different topics. And like restaurant and tourism, the industry isn't even something that I ever connected to blockchain before right now. And I feel like that is the type of thinking that we're going to have to start doing just as a society, but also from a technical standpoint, figuring out how to apply the blockchain and other emerging technologies to the real world and the things around us. All the topics that we've talked about in digital fluency, it's very exciting to me, and I think that there will be a lot of interest within William & Mary from every department, and that will be really cool.
Yeah, I agree 100%. Well, Troy Wiipongwii, director of the Blockchain Lab, thanks for being part of our digital fluency.
thank you for having me. I hope I gave some insight.
This was great, man.
Oh,
This
absolutely.
was great. And I wish I could stay and talk longer, but I got a lunch appointment I'm running off to. And Jacob, you guess what I'm going to order?
Ooh.
Blockchain. Gonna order me some blockchain.
Sounds good.
Give me
Before we sign off, is there somewhere online we could follow you or the Blockchain Lab for our listeners who are looking to learn more?
Sure. We are very active on LinkedIn. That's where we post most of our updates. But on the William & Mary site as well, we have the William & Mary Blockchain Lab site.
Awesome.
And it's a very long URL when you're on the William & Mary site. So
just Google William & Mary Blockchain
William
Lab.
& Mary Blockchain Lab, and you'll find everything you need.
That's right, yes.
That's the same way it is for STLI, right? Just Google William & Mary Studio for Teaching and Learning Innovation. You'll find us.
You'll
probably.
find us, yep.
Yeah.
Thank you,
Yeah.
interwebs.
Yeah.
Well, thank you both. Have a great one. We'll
Thank
see you
you.
next time.
Take care.